Today I'm going to be answering that age-old question, which vintage 8-bit system gets the hottest? First, I need to take a look at this tool, which is going to help me do just that. It's coming up right now on the Retro Hack Shack. Well, hello everybody. My name's Aaron. Welcome back to the channel. And yes, today we're going to be taking a look at several systems and we'll see which one hopefully is running the hottest in general. And there's a couple of different ways you can tell if a system's running hot or not. And the first way is just with this, with your finger. And I've shown this on the channel many a time, most recently with the TRS-80 Model 1, which is still hooked up over there at the moment. Yeah. Ouch. Ooh, yeah. That's hot. Woohoo! But yeah, if you think a chip is hot, for example, or you want to diagnose maybe some bad RAM, this happens a lot, you can just use your finger as a temperature sensing tool and you can start touching the tops of those ICs. And yeah, sometimes you get a little burned like I did. A lot of times chips will be warm to the touch, that's fine. But if they're too hot for you to hold your finger on more than a couple of seconds, a lot of times that'll indicate there's a problem internally, maybe a short internally on the chip, and that chip is probably bad. So that's the first way you can kind of measure temperature in your systems, and you don't need to buy anything for that. So it's very cheap and reasonable. The second way is with one of these, and I've used this on the channel as well. This is a infrared temperature sensor, and these are sold a lot for automotive. I think this is an automotive one, but it works fine. What you do is you just hold it to, like about, I think it's supposed to be 4 to 6 inches above the surface of the thing you want to measure. You press the button and nothing happens because this is out of battery. Okay, problem solved. I think there's some new batteries in here now. But yeah, as I was saying, I'll hold this a few inches above the table in this case, and I'll press and hold the button and it will give me a reading. So this is how cold it is in my garage right now as we're talking, 59 degrees Fahrenheit. So it's getting pretty cold. But you can see if I move my hand on the table and then take a measurement of that, it pretty much immediately jumps to whatever the temperature of that is. In this case, 78.5 degrees Fahrenheit. It'll show you what not only the current temperature is, the last temperature it was reading in this case, or it will show you what the max temperature is, in this case, 60 degrees Fahrenheit. Now, both of those tools, either the finger method or the infrared temperature sensor method, can be cumbersome to use because if you have a lot of chips to measure on your board, either with your finger or with that tool, you have to move it around, to 20 or 30 or 40 chips sometimes on some of these boards to see which one is getting hot. Now, today I'm going to solve that problem with this. This is a thermal imaging camera, and you may have seen these from other vendors in the past. This particular one is from Kaiweets. That's how I say it. I don't know if that's how you're supposed to say it. This is the KTI W01. So Kaiweets was nice enough to reach out and send this to me, and it was something I was looking for anyway. So I took them up on their offer. They sent this with no strings attached. So I'm going to go ahead and mark this as paid sponsorship because I'm getting something in return, essentially, for doing the video. But I didn't take any money from them in return for doing a positive review, and I made sure to tell them that I was going to review this as fairly as possible. So pros and cons, if there's things I don't like, I'm going to make sure to mention them in the video. I am very impressed straight away out of the box with the packaging that they have here. Really, really nice. This is the way it came to me. It's got this little magnetic clip that opens up here on the box. And you get this nice little boxes that you can pull out. I've noticed that vendors that want to go above and beyond and not just throw something else with an extra label slapped on, they're actually trying hard to get packaging that people like to open. It's the first impression of a device, and it's just a good unboxing experience overall. Now, in terms of Kaiweets, I do have this Kaiweets monitor over here. Let me grab that. If you look up some of the older videos on my channel, you'll find a review that I did of this. Interestingly enough, though, the reason I got this was because it was a low-cost meter, and it reminded me of Darth Vader. And I will say it served me very well. I've had no problems with it over the past few years or so. Let's go ahead and open up the first little box here. Looks like this is going to have some manuals in it. I do like the dark packaging as well. Yeah, that's an oversized packaging for the manual. But it's not so common that things have nice user manuals. I'm sure this is multi-language, but yeah, it's nice. The nice glossy paper. It explains the menus very well. Have the, oh, wow, a actually big case with a nice handle on it. I was not expecting that. I didn't know how big the actual product was inside. So I'm assuming that the infrared camera is going to be in here, and it is indeed. Oh, wow. Well, first of all, I've got to say, look at that molded box. So this always goes in one way, super protected for traveling if you're going to travel somewhere with it. That's pretty nice. This is maybe a power adapter. Yeah, we've got a power cord, in this case a US power cord, and I noticed on the box that they had different versions for different countries and a little USB power cord as well. And I believe this thing also allows you to take photos, and I think also you can use the cord to transfer photos and maybe even video off the device onto your computer. So pretty cool. So before I get out some old 8-bit systems to test, I do need to familiarize myself, so I might as well just go over what's here in the meter so I know what I'm doing. It looks pretty self-explanatory. It doesn't look too difficult. It's got some good information on this side in terms of the specs of the camera and what it can do. It's got a resolution of 256 by 192, temperature range either in Celsius or Fahrenheit there. It looks like it can do, down to about 0 degrees Fahrenheit, which is great, up to 550 C or 1022 Fahrenheit. So yeah, really designed to measure warmer things in the room, not colder things in the room. Of course, we've got the camera here and a little lens cap to go over it that just kind of sits on top, I guess, when it's done. On this side, there's really nothing except the brand name and a little rubbery pluggy thing to hook up the USB connector to. It looks like it's USB-C, so that's nice. And then we've got the face of the unit, the controls and things, and they're pretty simple as well. I mean, there's the power button, a menu button, enter for selecting things, I assume, a back button to back out of menus, and some navigating buttons to navigate around and do things there. So yeah, couldn't be any simpler, really, or at least it appears that way. Not having used it yet, I think I could probably figure this out, how to use it pretty easily just based on the simple controls. Oh, and look, it does have a little cover on the screen. So you know what we're going to have to do with that? We're going to have to go slow and pull this cover off of the display. Here we go. Whoops. Here we go. Cue the music. And there we go. No more protection for our screen. Risky behavior. And the other thing I should mention is the trigger here, which is used to capture images. So when you want to capture an image, you got it lined up the way you want. You can hit that and it'll capture a photo for you. And I think it also goes home. If you're in a menu or something, you want to get back to home, get out of the menus really quick, I think you can hit that to go back home. Oh, and I was looking in the manual, and behind the one of the handles here is an 18650 lithium-ion battery. So that's nice. You could actually replace the battery. I figured it was going to be one of those flat pack LiPo batteries that was stuck up in the housing somewhere, but no, it's actually a discrete battery that has a cord on it. You could actually take this out and replace it if you ever needed to. And that's plenty of juice in one of these batteries. They're pretty beefy. So I'm going to try my best to do this with a camera pointing at the device. We'll see what happens here. I'm going to go ahead and turn it on. Hold down the power button. Oh, there we go. It's coming up. And there we go. There's what it looks like. So I did put some things around to kind of warm up. So we'll take a look at that. I want to test the camera functions to make sure I can take pictures for our evaluation of those old systems. In case you're wondering what that thing is down there, that is actually the power brick for the TRS-80. That's the power supply for the TRS-80 Model 1. And it looks like it's glowing red hot here in the image, but it's just because everything else around it is pretty cool. So you can see there's a green sensor up here that's showing me the minimum temperature. And then, of course, there's red text there, which says 76 Fahrenheit for that power supply right now. And then there's always in the middle, this middle, like whatever you're looking at, kind of average temperature, which is 59. It also shows you down here, there's a max value, which is that 76 from the that power supply. It doesn't get very hot, actually, surprisingly. And then there's a minimum temperature, which is 58.4. All right, so let me go ahead and take a quick picture, and I can blow this up on the video, and we'll see what it looks like. Now, this also has the ability to take video as well. So you just hold down the capture photo button, the little trigger thing, and it says start recording, and I'm going to say yes. All right, so I'm going to walk around here to the garage to where some of these computers are in the back, and you can see there's some hot spots back there, and what those are is the power supplies. That one on the right there is a Commodore, rebuilt Commodore 64 power supply, and that's running about 84 degrees Fahrenheit. And then if we move over here, there's that little glow back there is an Atari power supply, and that's looking 78, 79 degrees Fahrenheit back there in the back. The overhead ceiling lights, the fluorescent ceiling lights, are reading pretty hot, 100 degrees Fahrenheit. And this is my camera. And you can see the camera actually that I record the show on is actually running about 80 degrees. Let me see if I can get the... Okay, so down there, it seems like down there where the battery is perhaps or something like that is running about 98 degrees Fahrenheit. Now, in the community on my channel, I asked you all what you thought was the 8-bit computer that gets the hottest. And so here we have the results of that survey so far, and you can see that the Commodore 64 is losing? I don't know, that poll by a long shot. So as it stands right now, 49% of you thought the Commodore 64 would be the hottest computer of the bunch. Second hottest system is the Apple II, and then the TRS-80 comes in the third place with 14% of the vote. The TI-99 comes in after that with 12% of the vote, and then the Atari 8-bit. So you guys think the Atari 8-bit is actually a cool running 8-bit computer. And so, yeah, we'll have to see if that holds true. So the first system, let's just go in rank order with the hottest system first to see if anything can get hotter than that. And that would be the Commodore 64. And it even came with this leatherette covering case. Not that it's great. Oh, this one has no video. Okay, back to the drawing board. Let me find another one that's actually working, because I do at least want one that's working. Okay, after several attempts, I found one that is working, and I believe this one should be stock. So this will be a good test. No mods, no heat sinks on the chips or anything like that. Let's start with this Commodore 64. Wow, well, I don't want to make this video too long, but I opened this thing up, and it was a 5-pin video connector on here instead of the 8-pin, so I knew this was old, but this is absolutely a Rev A from 1982. So first year Commodore 64. This will be a good test because it will most likely, since it hasn't been optimized, it will most likely generate the most heat, or that's my assumption anyway. And also this PLA, I don't know if it shipped with Rev 3 PLA. Those Commodore 64 experts out there can correct me if I'm wrong, but this is definitely 8411. Ooh, and that's coming right off. Coming right off, and it doesn't even have the MOS markings on it or anything like that. But yeah, this is a Rev 3 PLA. So maybe that was added later to fix some bugs. But other than that, this thing is as stock as you can get. All right, so with each of these systems, I figure I'll plan on leaving them running for about, I don't know, 15 minutes or something like that, just to make sure that they're warmed up. I did test running these under load, but it really didn't make a whole lot of difference. These are, obviously single core, old school chips here, so they're always running pretty much as fast as they can all the time. You might load down some of the individual chips a little bit, I guess. Maybe the VIC had more activity going on or something like that, or more reads and writes to memory. Maybe things would get a little bit hotter there. But yeah, I've had this thing running for a while now, and I'm just looking at the various chips. And what I thought I would do, other than taking a picture of the board and trying to figure out what the average heat value was, I thought I would also maybe try to figure out what the hottest chip is and then somehow add that into the equation as well, or at least have it as a separate data point. Right now, the hottest chip looks like the SID chip. It's 142 degrees Fahrenheit. The VIC, which is the one, by the way, which has the heatsink on it most of the time, is not really hot at all. And it may be because this is a ceramic package. So the whole thing is kind of acting as its own heatsink here. And then, yeah, the CPU is 126. Looks like the ROMs are actually kind of warm, 132 degrees. Although they don't feel warm to the touch, I'll be honest. If that's 132, yeah, that is kind of warm, I guess. So, and then the other interesting thing about this is right over here, I'm noticing that there is a capacitor or something that is pretty hot as well. So that's getting up into the 140s, depending on how I hold the thermal camera. So all the other ones are dead cold, but this one, for whatever reason, is super hot. So in terms of troubleshooting, I mean, I would have never suspected that that thing's getting hot. But it is. So yeah, something around here, I think it's that, is going to have to probably should be replaced. I'm going to compare that with image on another C64, and just to make sure that that's not something that is always just hot because of the way that they designed this thing. So it looks like the hottest chip right now is the SID chip, so we'll use that as the high mark. I'm not going to count, of course, the regulators. The regulators are also very hot. I think 172 right now. So they are pretty hot right now, but I'm not going to count those in my measurements, but I will count them in the overall measurement of the unit. So it's time to take this picture. Then in a little bit, I'll show you how I'm going to calculate the average temperature. Okay, so we're moving on to an Apple II. This came in number 2, second most hottest as voted by you, the viewer. And yeah, as you can see, it looks like things are getting kind of hot, but really the max temperature I'm seeing on any of these chips is about 120, and that is coming from this little chippy here. And it's really, I mean, I have to really, oops, that's the wrong chip. This one? Yeah, if I leave my finger on there for a while, I can kind of feel that it's getting hot, but it's really not getting that hot at all. So this is a stock Apple II. Since we use that like older model Commodore 64, I thought I would use an older model Apple II instead of like an Apple IIe that has the reduced board and stuff like that. The more chips on this, the better in terms of heat, or the worse in terms of heat. So I figured we would go with this to try to keep things as similar as possible. And although things look pretty yellow, hopefully you can see in the video image, these aren't burning hot or anything. I mean, these chips are, like I said, the hottest chip on here is 120 degrees, which really isn't that hot at all. Fahrenheit, by the way. So not hot at all. The other chips that are kind of glowing in the picture are 114, 115. We can check the CPU up here. It is kind of getting hot, but that's still around 100, 109, maybe, or a little less than that. So yeah, this really isn't getting too hot at all. It doesn't seem like this is going to be nearly as hot as the Commodore 64. And just like on the Commodore 64, where the VIC-2 chip wasn't getting as hot as you might think it would, most of these memory chips are ceramic. So the one chip that I had to replace on this board, which I replaced with a non-ceramic chip, that one is getting quite a bit hotter, even though it's really not that hot to the touch at all. Because again, the ceramic is just a great insulator, and it's not letting that much heat out of these chips. Well, here's a interesting problem. I was letting this TRS-80 Model 1 heat up, and guess what? One of the memory chips, that's right, the one that's glowing that says over, is in the middle of a massive failure. In fact, I can see that in the camera here, I can see that the chip has bubbled up. So this thing is over what this thing can measure. And remember, this measures 1,000 degrees Fahrenheit, and this is too hot for it to measure. And I'm smelling the burning plastic here of that chip. So I'm going to take that out and restart this experiment. But yeah, I wouldn't want to put my finger on that thing, that's for sure. Way too hot. Okay, now we're in a little bit better place. We don't have any chips that have busted their guts all over and released the magic smoke. But it still smells like magic smoke, I can tell you, in the garage. Anyway, the TRS-80 has been running for a little bit now, and this may be a little unfair here because the TRS-80 has one of those big TO package 5-volt regulators here. And so, you know, that's going to run hot. It's running 146 or so degrees Fahrenheit right now. So yeah, that's going to skew things a little bit, but look at the rest of the board. The rest of the board is looking pretty good. The CPU up here, the Z80, is 108 degrees, cool, calm in the shade there. And yeah, the only other thing that looks hot, there's one little chippy down here that's been replaced. 112 degrees, no big deal there. And then the AC rectifier here with those diodes in there is, yeah, running a little hot, 130. The thing that's going to get me in trouble here is this big cable that goes to the ROMs on the underside, and I'm not going to be able to measure the ROMs. I'll feel them with my fingers just to make sure they're not too hot. If they are, we'll have to figure something out. But yeah, I think I'm just going to have to figure out how to move that cable out of the way and then take my picture. So wish me luck. Okay, so it's time to move on to the next test in the Heat Wars, and that is the Atari 800. Now, I can hear some of you saying already, hold on, buddy, hold on, Aaron. That is not an Atari 800. Well, it's right. It's not an Atari 800, and there's a good reason I'm using, at least I think, that I'm using this particular model instead of an original Atari 800. The original Atari 800, as most of you probably know, had a huge metal enclosure that was there for RF purposes so that it could pass the FCC test that they used to do on these systems for interference. And although you can take your time and take one of those systems apart, I don't even think I have an original 800 actually. I've got an original 600, and then I've got all of the XL lines, but I don't have an original Atari 800. But even if I did, it would just be a real pain to either take that shield apart, or if I didn't take all that stuff apart, it wouldn't be a very good representation with a big metal shield blocking half of the motherboard. So anyway, I went ahead and decided to use the Atari 800 XL, even though on all the previous systems I've tested, they've been early revisions of those systems. I don't think it's going to throw things off too much. And anyway, this is just for fun. So there's so many things that you could say that are wrong with the way that I'm doing this testing, but it's just for fun, and it's just to see what comes up in these tests. So let's go ahead and take this apart and make sure it's still working. And oh man, I forgot about this RF shield that's like so hard to get off because the screws are on the underside of the RF shield. So, well, I don't have an original 800 anyway, so it's going to have to be this no matter what. But in terms of saving time, yeah, I still have to take off this shield, which I have to take the motherboard completely off and then unscrew these. It's got screws with bolts, and the bolts are on the upper side and the heads of the screws are on the underside. So you have to take all of this out. So I forgot about that, but it doesn't matter. Let's continue with the tests. Okay, well, here is the Atari 800 XL. It's been running for a little over 10 minutes. And yeah, about the same as the other 6502 based machines. This is the, this is the CPU here, and it's labeled differently. Atari, instead of just labeling it 6502, which would have been nice, they actually had to go out and put their own model numbers on all these chips. So I actually had to go look it up to see which one was actually the 6502. But this is it here. It's the hottest chip at about 120 degrees or so. And this chip up here looks like it's really hot, but it's actually about 113. And not actually sure, can't tell from here what that is. But yeah, memory. This is all plastic memory, none of the ceramics, so that can tell you the difference in the, show you the difference in the ceramic that we saw earlier and the plastic IC packages here. They look like they're pretty hot, but actually they're about 100 degrees or so each. You know, nothing that you can't stick your finger on and leave it there for as long as you want. It's, you never have to pick it up. It just is nice and warm, which is kind of nice because it's cold out in the garage. That's the Atari 800 XL. Okay, well, what we have on the table now is a disassembled Texas Instruments TI-99 4A. And boy, if you've never taken one of these apart, it is an adventure. First of all, I had to make up a special cable to get composite out because the modulator wasn't working. It comes with 12, it actually comes with 12 volts out right next to the video line here. And that goes over and powers up a modulator, which I've taken apart here. So it actually powers the 12 volt, powers up this modulator, and then that converts it to RF, and the RF, of course, comes out and goes to the TV. That wasn't working almost at all. I could see a few things on the screen like trying to come through the RF, but yeah, it wasn't working. So I made up my own cable. That was step number one. Step number two was just disassembling this bad boy, because there are all kinds of layers of shielding that you have to remove, luckily not soldered, and then those are clipped together with some clips, and the Whole thing is held together with a bunch of screws and bolts. So those are up here. So it's quite an adventure. Now, when I got into this thing finally, there was a heatsink on the top of the shielding. There was a big long heatsink on this chip right here, and it's just like slathered on there. So I want to, as it's heating up here, and I'm giving it time to heat up so we can do a comparison, I do need to, or I want to get this heatsink compound, this old heatsink compound off of here, just because it's so messy, number one, but number two, so I can get an accurate reading on this particular chip. I'm assuming that's probably the video chip, but yeah, let's see if we can get that off of there so we can do a test. And indeed, this is the video display chip, and it does get quite hot. Obviously, since that heatsink was on there, it kind of naturally, I believe, is just one of the warmer chips. And I think there's a way that I might be able to get RGB signals off of this board and then send those out through HDMI. I actually have 3 of these TI-99/4As, and I've never covered them on my channel. 2 of them are working perfectly. They're just missing some keys. And then I have a silver one, which I believe is the older model. Correct me if I'm wrong. And it does have some problems with characters on the screen. So I could do a repair video on that and also do an RGB or RGB to HDMI mod. If you want me to do something like that, let me know in the comments below. Interesting to note that this newer style, I believe the black model that I have has an LED that actually faces out, and you can see it come on when you turn the power on. This also has an LED, but it's facing inside the case. So I'm not sure what's going on there, but it does come on. It's just very, very dim, and it's like literally bent over. I don't think there's even an access hole on the outside of the case to see if this LED is on or off, but it's still there. So that's pretty interesting. Maybe they reused the existing power supplies that they had in stock and just bent that LED in because they didn't have a hole for it in the outside of the case. Also, there's some bodge wires here, and if I remember correctly, seeing other videos and things, that's fairly standard for TI-99/4As, is to have those bodge wires in there from the factory when it was brand new. All right, well, here we are. The system's been running for about 10 minutes or so, and by far the hottest chip on the board is this video chip, so it's no wonder that this had a heatsink on it, because that chip gets up to about 140 or so. I just put my finger on it, so it cooled it down a little bit, but it was getting up to 142, 143 degrees. So I think that's the hottest chip we've seen in this 8-bit shootout so far. So that is going to negatively impact, although, you know, that is by design probably. It's just the way the chip came out, and it does have a heatsink built in by default. So can't complain too much, but we're here to measure things. So about 142, 143 on that chip right there. The CPU itself is running, you know, hotter than the 6502 variant, so just by a little bit. So this is running about 125 degrees. The big CPU here, the Texas Memory 9900. Nice to have a different CPU to compare with. And the rest of the board, you know, the memory and all that is pretty much on par with what we saw. These are also the plastic, no ceramic chippies in here. Plastic chips, and these are on par with what we saw with the other plastic memory chips as well. And then this system also has the power supply right inside the box. So there is a regulator in there that's getting pretty warm, 138, 139 degrees. But interestingly enough, that is a little bit cooler than the video chip here, is now up to 145. So it seems to be fluctuating and going a little bit higher even as we kind of sit here and talk about it. So yeah, let me go ahead and take a picture of the entire system, and we will go compare these. Okay, so let's talk a little bit about the evaluation of these temperatures now. There are a lot of tools out there for more expensive cameras, like the ones from FLIR and others on the market, where they come with some pretty good analysis tools, thermal image analysis tools. What I wanted to do was take a look at some of these pictures that I took with the camera and then kind of evaluate them, maybe get some histograms or at least see what some of the temperatures were of the parts that maybe I didn't examine when I was doing it live. And I didn't see any software. So I reached out to the vendor Kaiweets and I said, hey, do you have any thermography tools that come with the camera? They said, yeah, all you have to do is plug in the camera to the computer, and you can see there's a Windows application right there that you can just click on and install. So like, duh, of course, I should have looked at that. We've come a long way since getting software on floppy disks, then CD-ROMs, downloading it off the internet, and now you just plug in the tool that you buy and the software you need is right on the tool itself. Pretty cool. Anyway, so I looked on the camera when I plugged it in, and sure enough, there was this IR image tools software. Let's go over how it works, and then I'll tell you some things that I don't like about it. So the nice thing is you can open a file here, and we can pick one of these files that I captured, and you can look at the file. You can look at when the image was captured. It captured not only the thermal image, but it also captured what was on the screen in terms of the temperatures, I believe. So you get this 153 degrees Fahrenheit here on this regulator on the C64, and then you get the coolest temperature, which was over here at 59 degrees. And then there's other tools here. I can use the spot tool to go in and, like, let's say we want to take a look at the VIC-2. I can actually click on that and click around and get some temperatures, 116 degrees for the VIC-2 there. And then I can back up and take those off if I wanted to. And I can use circle or square or different things. And I can get the same high and low temperatures for different regions of the image. So in this particular square that I drew, the hottest temperature is, of course, the SID, and the SID is 126 degrees Fahrenheit, and the coldest temperature there is in the corner at 64 degrees Fahrenheit. So that's kind of cool. And if you had an irregular shape, you could use a tool like this freehand tool, where I could, go in between chips if I wanted to, and kind of make up my own little region to analyze, and it will do that as well. So that part is pretty cool. I like that. The other thing you can do is it captures both the infrared image and the regular visual image. So I can go ahead and turn this little dial down here, and you can see the actual image on the screen. Unfortunately, I didn't have the camera set up quite right to align these exactly, but it is kind of helpful. And if I did have this aligned perfectly, it would give me a little bit better idea of what was going on if I couldn't make it out from the thermal image. You also have different palettes to choose from. I'm on iron right now, but you can go with a cool palette, a white palette, or a black palette where it reverses those images. That one kind of looks like a negative. There are some things, however, that I don't like about this particular tool. One is I can't resize it. So I can move it around, I can minimize it, but I can't maximize it or resize it. This is the size that you get, and you can't change that at all. Also, it is a little bit difficult. I would like a little bit more analysis going on in here, maybe to see a histogram or things like that. What I wanted to do with the temperature was to go a little bit deeper in the data and be able to maybe isolate some things or just see a histogram might give me a little bit more information, but this tool really doesn't do that. So what I did was I grabbed the little square tool and made an outline around where the case would be, the lower case, or just the outline of the motherboard, if that's all that was on the table, and then just captured the lowest temperature inside of that area and the highest temperature. And I also looked for the highest temperature CPU with the little point tool here. So I did that. And actually it works a little bit better. If you do want to just check out that chip, I found it looks a little bit better to do the box, because instead of trying to find the hottest point, it's easier if you just do the box. It'll automatically find the highest point, which is that SID chip there. So that's what I did, and I got the hottest temperature, the coldest temperature, and the hottest chip for each system. So then I put all of those values into a little spreadsheet here. I looked at the high temperatures, the low temperatures, the hottest chip for each system, if there was a power regulator involved, some sort of power causing a higher temperature, a high temperature. I put that in as well. I looked at the median between the lowest temperature and the high temperature just to see if I could come up with a good way to take a look at the temperatures and come up with a pseudo idea of which system is the hottest. And this is what I came up with. So you can see all of the systems represented here. Commodore 64, for example, is blue here. If we look at just the hottest temperature in the picture, in the thermal image, which includes any regulators that might be there on the form factor that is inside the case for each of these systems, then you can see that the Commodore 64 is the hottest system, followed by the TRS-80, because of that regulator that's on the board there, followed by the TI-99 because of the video chip that gets really hot, followed by the Atari, and then finally the Apple II was the coolest system when you look at the overall picture and what the hottest area of that picture is. However, if we take out the power elements and just look at the hottest chips on the board, then actually the TI-99 becomes the hottest system, even though that was ranked last in the survey. That becomes the hottest system because of the video chip. And actually, when I took the picture, the temperature was a little lower on video. If you saw the temperature of the TI-99 4A, the video chip actually got up into the 140s. So by far, and of course, that's going to have a heat sink on it. But if not, that makes that the hottest system. Again, followed by the Commodore 64, and then followed by the Atari 800 XL, the Apple II, and then the TRS-80 in the hottest chip test comes in the lowest. So if you take out the power regulation, the TRS-80 is actually the coolest system of the bunch. And if you include the power regulation, then the Commodore 64 becomes the hottest of the bunch. Either way, you can see here the Commodore 64 actually ranks pretty high in both of these. So I think we can say that probably the folks that voted for that on the poll got that one right. But what they missed was the TRS-80 and the Apple II actually ranking very low in the hottest system data here. Again, this is just for fun, not scientific at all, probably not the best way. You guys can leave comments down below nicely for each other, commenting on the way that you would conduct this test. And if there is something that you want me to follow up with, like if you want me to test these systems under load and someone could provide me with some code that will equally stress the various systems, try to make it as equal as possible, and you want me to test this under load and see what happens, I'm happy to do a follow-up video with that information. Just get in contact with me or leave it in the comments and I'll try to do a follow-up if folks want me to. But I thought this was pretty interesting. So I think that vindicates most of you who voted in the poll saying that the Commodore 64 would get the hottest. Depends on how you look at it, of course. There's many ways to skin this cat. Many people in the comments said that they remembered their Apple II getting really hot and they had to buy an external fan, one of those ones that hangs on the side. I wasn't particularly trying to measure the efficiency of the ventilation in all the cases, but that's another round of testing you could do with a little sensor that goes inside the case. You could run it, maybe run some load on it and measure the internal temperature with the case on, with all the shielding on, to see what would happen there. There's tons of permutations that you could take when doing this type of examination of systems, but this was a lot of fun to do. I do like this tool and I'm going to be using it more on the channel for sure. As far as price for this particular tool, this Kaiweets KTI W01, well, as of this recording of this episode, this particular thermal imaging camera is on sale at Amazon for $299, basically $300. However, when I looked at it, there was a $60 off coupon that you could click. Still pretty expensive, but it's definitely in the realm. If you look at other thermal imaging cameras, in fact, you know I'm a cheapskate, and that's why I haven't bought one until this point, which is they're just expensive, you know. And if you don't need one, if you can just use that tool that most of us were blessed with or have available to us, the finger, to check out those chips and which ones are getting hottest, you might not need a tool like this, but it is a big time saver. I'm going to be using it to look at like random things like that capacitor on that C64 that I wouldn't have ever suspected was maybe getting towards or creeping up towards a failure. And something like that is really hard to diagnose after the fact. You basically have to go around and test all of the resistors and capacitors at some point to find out which one's not working. So if a tool like this can help me with that, it's going to save me a ton of time as I'm producing videos and working on these systems. I've got other videos on the channel that you might be interested in, so I'm going to go ahead and put one of those up here, and I'll see you in that one coming up next.
End of line.